Now we're going to get into section 5.6, ratio and root test. So first off, we're going to deal with this series that we have to the right here. But first, let's talk about what the ratio test is. So first off, it says let a sub n be a series with the non-zero terms. Okay, so the terms are non-zero. Okay, next it says let rho equal this limit here, and that's really what we're going to be dealing with for the most part for this test. We're going to be dealing with this right here. And then it says once we get a number for that, if that number that we get for this limit is going to be between 0 and 1, not including 1, then we can say this series converges absolutely. If that value there, that limit equals here, is greater than 1, then we can say it diverges. And if it equals 1, then we can say nothing. So this is kind of what we're going to deal with this problem. So our big problem here is actually finding this limit here. So what we're going to do then is we're going to start with what is a to the n plus 1. So our a to the n for this series is 10 to the nth over n factorial. This here is a sub n. But if I want an plus 1, I'm simply going to plug in n plus 1 in for n. And I will get this for that an plus 1. So now if we're going to plug this into this row here, and my row is the limit here, as n goes to infinity, I'm really looking at the limit of 10 to the n plus 1 over n plus 1 factorial all over, and then a sub n is just 10 to the n over n factorial. So if we look at this an plus 1 is just what we see up top, and then our an, which is down here, is what we see down below. Okay, so let's get started now on this limit. So then this limit here, as n goes to infinity, is actually going to equal 10 to the n plus 1 over n plus 1 factorial. And this would be, I could turn this into a times here, because think about this here. This is division, and what is division with two fractions there? It's I copy the first thing down, and then for this bottom expression here, I'm going to flip it and multiply. So that's what we're going to do here. So this is going to end up being n factorial down here over 10 to the n. Now there's a few things that happen here. I'm going to change colors because I want you to see what's going on here. So this n plus 1 factorial, if you think about factorials, like 3 factorial will be 3 times 2 times 1. So it's like I'm counting down here. So for this n plus 1 factorial, I get n plus 1 times n minus 1 all the way down to 1. I could say 3 times 2 times 1 if I wanted to, just to kind of get an idea of what's going on there. And if I have this one up top, what is n factorial? It's n times n minus 1 times 3 times 2 times 1. And then also I can break this 10 to the n plus 1 down. I can call this 10 to the n times 10, because when I'm multiplying, what do I do with my exponents? I add them. And this second 10 here is really 10 to the first power. So that's where I get that n plus 1 at, because I add my exponents when I'm multiplying. Okay, and the reason why I break this down this way, because I really want you to see how this cancels. So now when I'm taking a look at this one here, if you think about this, all of this right here, oops, will cancel with all of this up here, because I'm multiplying here, so I get simple canceling top to bottom. Okay, and this 10 to the n here will cancel with that 10 to the n. So really, the limit I'm actually dealing with here, and this is what makes the ratio test so nice to work with, because this is just a simple sort of algebraic cancellation. I'm going to get a 10 on top only. If you see everything else canceled out. And then on the bottom, I'm really just going to end up with an n plus 1. Now, one thing to keep in mind when you do this canceling, it actually is a 1 in its place. So if everything cancels, it'll just be a 1. But this is actually what we end up with here. So now from here, one thing you'll notice is what happens here. As I go to infinity, this actually goes to 0. So this limit actually equals 0. So let's kind of see what that means for this series. All right, because I definitely didn't give myself enough room to finish writing this answer out completely. But if I take a look at rho is actually this first case here. It's actually between 0 and 1, but it can be equal to 0 as well, and that's what we see here. So then this simply tells us that the series converges absolutely. And that's kind of what we're looking at here. So that's a nice handy tool for us now. So what we would write for this is, given all this information that we have here, I'm going to move to the next page, and I'm going to say this implies that the series converges absolutely. And do you guys remember what theorem I said we were going to use from the last section? Here it is. This implies that the series n equals 1 to infinity of 10 to the n factorial converges by this theorem. Which for a test or a quiz, you don't have to write that by the theorem. It's understood, I guess, at this point. What you do have to say, though, that it does converge absolutely, which implies it converges. That would be enough for me, because you're actually just restating the theorem. Now remember, the hardest part of a problem like this is, let's take a step back for a second. Honestly, it really comes down to all of this algebra here. This is what is going to be the more difficult part of this type of problem.